We're going to be talking about how to use the normal curve to help us find statistical values, dealing with mean and standard deviation. So on the third page of this packet, there's a picture of the normal curve, and it breaks down by percentages what percent of people would fall in these certain ranges. So mean would be in the center. This would be your mean. This would be your x bar, whatever number that is. And then when you have that standard deviation, by adding or subtracting that standard deviation, you could figure out, let's say I was one standard deviation away, you could figure out from this that there would be from 0 to 1, there'd be 34.1% of the numbers. So we'll be using some percentages, doing some proportions, and multiplying percents as decimals. Now, going through the questions, I'm going to go ahead and minimize this, put it over on the side. Going through the questions, you can kind of see, for a population normally distributed, find the percentage of population that lies within one standard deviation of the mean. So one standard deviation would be from +1 all the way to -1. So you'd have to add those percentages together, which are two 15% and two 19.1%. So together this would be a total of 68.2%. And then within two standard deviations of the mean, well, you're going to encompass everything from -2 to +2. So in the case of this, we have also these 4.4s and 9.2s, which would be 13.6. So we have the 68.2 we already included, plus two areas of 13.6. So in this case, if you multiply the 2 and the 13.6 together, you get 27.2. You'd add that to 68.2, and you get a total of 95.4%. For C, it says more than 3 standard deviations away from the mean. So in the case of, you can't really see those, but each of them are 0.1. So if you're more than 3 standard deviations away in either direction, you're only 0.2%. And between 1 and 2 standard deviations above the mean, so that would be this area here, 1, 2 above the mean, which again we just talked about earlier is 13.6%. So you want to look at the wording, be very careful with it, and then take into account those sections that go with it. So, going into exercise 2, I'll go ahead and erase all this. Arlington High School, we got 424 juniors took the SAT. The math portion, the mean score was 540 with a standard deviation of 80. So if the scores on the exam were normally distributed, they want us to answer the following questions. They want us to figure out certain percentages, and then they're going to ask us how many people fell within those percentages. So, what percent fell between 500 and 660? Well, in this case, what you'd want to do is take this normal curve and figure out what numbers actually match up with those values in the normal curve. So what I mean by that is, it says the mean score is 540. So that means that 0 in the middle is 540. And then standard deviation of 80 means that if I wanted to get to 1 this part and -1 this part, I'd have to add and subtract 80 to those values. So this would be 620, and the other side would be 460. So by adding 80 each time, I can find the next value. So 2 would be 700, -2 would be 380, -3 would be 300, and +3 way over here would be 780. Now, in the middles, for the 0.5s, those are going to be because you go up by 80 for 1. This would be going up by 40. So, like, this would be 580 and 500, and then you can kind of fill in the rest as we go. And we'll do that if we need to. So it says, what percent of the math scores fell between 500 and 660? Well, here's 500. And 660 would be 1.5. So here, so we'd have to add together all the percentages in between those sections. So we got 19.1, 19.1, 15, and 9.2. So you can go ahead and take your calculator and add those parts together. And in the case of this, we get 38.2, 53.2, and 9.2, which would be 62.4%. Okay. So more than half would fall within those areas. So now they're asking us how many scores fell between 500 and 660. Well, in that case, if we want to do that, you can use a proportion, or you'd have to find that percent of that total amount. So two ways you could do this. You could do 0.624 times 424. That would be one option. Or you could do a proportion, which would be 62.4 over 100. And then how many x over the 424 students. Because 100 represents the total. So if I go through and I do that, let's say I do that first one. I do 0.624 times 424. And again, I'm going to have to round to the nearest whole number, so this is going to be 265 students. So 265 of those students fell within that range. Now it says for C, if Evan scored a 740 on her math exam, what percent of the students who took the exam did better than her? So if she scored a 740, that would mean over here, she would have been 2.5 standard deviations above the mean, which means there's only two sections left in this case. There's the 0.5 and then there's the 0.1 section. So in that case, what percent of students did better than her? Well, in this case, it's just 0.6% of the students. And for D, how many students did better her as an amount? It will be 0.6 or 0.006 times 424. So in the case of this one, 0.006 times, in this case there'd only have been 3 students, if we round it, approximately 3 rounded, that did better than her if she was able to get a 740. Now let's try another example. If you go to the next page, exercise 3. So it says the heights of 16-year-old boys are distributed with a mean of 66 inches and a standard deviation of 3. And if Jabari is 72 inches tall, which of the following is closest to his height percentile rank? So a percentile rank is just a ranking from 0 to 100 that goes through what percentage they fall and what percent of people would be below them. So in the case of Jabari, he's 72 inches tall. Well, we know the mean was 66, so I'm going to go back to my normal curve. I'm going to erase all my data here. We know 66 is the middle, standard deviation is 3, so that means 69 and then 72. So Jabari is 2 standard deviations above the mean. Now there's 2 ways you can kind of figure this out. One way is by taking all of the percentages below and adding all those together, or you could take the percentages that are above and then subtract that from 100, which that's the way I'm going to do this. So I have 1.7, 0.5, and 0.1, which would be 2.3%. So only 2.3% of the people would be taller than him. And in the case of figuring out what percentile is in, you have to do 100 minus 2.3, which would end up being 97.7%, which would mean that he falls in the 98th percentile. So, in the case of Jabari, if there was 100 people, he would be in line the 98th tallest out of those 100. Now, looking at one other one, if you look at exercise 4, soda in a can is distributed with a mean of 12 ounces and a standard deviation of 0.6 ounces. Okay. If 250 soda cans were pulled by a company to check volume, how many would be expected to have less than 11.1 ounces in them? So again, we're going to go to that normal curve and we're going to label it. So it looks like the mean is 12 and the standard deviation is 0.6 ounces. So in the case of this, that would mean that going each direction, we'd have to add 0.6 and subtract 0.6. So I'm just filling in some of those numbers. And then it says 11.1. So 11.1 is going to be negative 1.5% standard deviation. So we got 11.1. I just wrote that wrong. I'm going to cross that out and put 11.1 up here now. So if 250 cans were pulled, how many would be expected to have less than 11.1? Well, we need to find the percentage. So if we add up those percents from there over, you got 4.4, 1.7, 0.5, and 0.1. So that's going to end up being 6.7%. So we got to figure out 250, what number is going to be 6.7% of 250? So if I change that to a decimal and then multiply it by 250, I'll get my calculator out for that. 0.067 times 250 ends up being about 17 of the cans. They have to pull 17 cans to do the checking of the volume. So try exercise 5 on your own. And again, they're going to have you do the calculations for the mean and the sample standard deviation. So you'll have to write those calculations first, and then you'll have to use the curve to help you find the answers for the other parts.